I've worked on. I mean, we work here with AI every day, and there's in the .com field. There's companies that are coming up with really expedient AI, right? Like we figured out classification generally. I mean, like 40s, 50s, and a lot of the theory was already done, but now we just have faster computers. So you just see, okay, you know what, you can just use Google or Amazon. They've got these APIs. You can just upload it. Can tell you the difference between a penguin and and a cat. However, there's still the kind of the hype surrounding it, going, well, if you twist the penguin's picture 30 degrees to the side, it'll think that it's a shoe. So, and then you have to go back, oh, well, I need to train it on that stuff. So it's only good as the training data, and ultimately the human being is going to help classify it. So when people say, what AI is going to kind of take over the world or be capable of truly original or novel thinking, my contention there is that, mathematically, it's just a really efficient form of just, Lego, right? Like, you're still got the original pieces, but who's going to come up with a different piece of Lego? And I think that's where the novel thinking is going to come in. Mathematically, we're not there just yet. So, a lot of journalists, and I know I'm going to get a lot of, the comments and the flack on this, from the comments on this thing, that we're not quite there yet. It makes for a great kind of commercialization. But to the, your point, if we can help catalog these things a lot faster, I mean, absolutely, there should be this congress and this conversation between the people who are making the tools and, people who need to use the tools for classification. But for an AI to come along and say, well, I'm going to now, instead of outsourcing data cataloging, I'm going to outsource thinking itself. So if I kind of work my way up my mental pyramid of sorts, where it's no longer just hands, it's actually the cognitive processes where I'm able to perceive of not only just, senses that have somehow differently been abled by AI. That's when stuff starts to become both exciting and frightening at the same time. Because imagine, I mean, we perceive of a certain way of doing things. We have a certain ethical and kind of a moral compass and societal mores within which we kind of operate. And we've tried for the most part to endow AI with these types of things. But if we just say, look, here's what you need to optimize, it's just profit. And then it can run away. And as we've seen to sometimes, disastrous effect, where for the price of just going out and making profit, it'll just let anyone bid on anything, whether it's advertising and if you start deploying it in other areas where we start to literally give it arms that it says, okay, well, this is okay for me to kind of cut my losses on, or this person isn't as important, or let's not worry about that election as much because we need it to earn the profit without taking any company names. Right, this is where for me, like, we need to start making those trade-offs. But in the meantime, it sounds like there's so much application just for fields in, they can catalog galaxies, for instance, right? Like, because that might help us discover, to your point, how stuff works.
Well, but I agree with everything you said there. I think, so there's a saying, with great power comes great responsibility. And I think what you're talking about is that we're starting to recognize that AI has power. Right. It has when you're talking about, bidding on things, changing the world economy because half the trading going on is done by computers and, can crash the entire monetary system if an AI system, is not whatever. That's real power. That's power, to run commerce. And the more power we put in the hands of AI, the greater responsibility we have to make sure, as you said, it's being done ethically, right? And there is a movement, to try to make people aware of this, and things are changing. I thought it was really interesting there. Google finally said they're not doing any more military contracts, and of course they didn't say why or exactly what they were working on. But if you had an imagination, you might think, these guys were building AI for killer robots and recognizing that, like, if we build this so efficiently and we put it in the hands of, say, people we don't have the same moral values of, what's happening with society? And so even if there's profit to be made here, which I'm sure there is plenty, we're going to take ourselves out of this. And so, it's scary, but it's good to know that at least, some people are trying to think ethically and recognize the real power in this kind of stuff. So that's something we have to realize moving forward. It's powerful, and we have to be responsible.
But in a strange and perverse way, to circle this back, this was all caused by NASA and and been inspired because you create this entire like arms race of technology that the astrophysicists and the people who wanted to go to the moon created computers, and now we're just using that to kind of enable commerce. Yeah, granted, commerce has been around forever and a day, but like there's certain like noble, more noble endeavors that we can certainly be putting this forward that aren't necessarily going to be kind of harming society.
Yeah,
right? People
absolutely.
want to develop these STEM skills and kind of go into it. Right?
Absolutely. So there's a huge future in AI. Excuse me. There's a huge future for AI and science as well, and we're just trying to figure out what that is.
Is that something that you are interested in right now from the data that you are gathering? And was AI used to look at this, the picture of this black hole, or is it going to be used in James Webb and to be able to,
So presumably, I'm not
data?
doing. So I've kind of, on purpose stayed a little back from the AI revolution at the moment. I think just because there's a lot of things I'm interested in that don't need it, and right now, it's a risk, right? Here you guys are probably always making these R&D choices about, what is the long-term investment of my R&D? This could become something huge, but it might take 10 years, and this might be something smaller, but I recognize that, you're always making these trade-offs. And so in my own research, I sort of see a lot of exciting stuff on the horizon. And my friends who are using AI, I think, 20 years from now, I'll be jealous, and I'll probably have to catch up. But right now, I'm not doing so much of it myself. It's really useful at the moment, as you say, on these cataloging things, these big tasks that you would get, back in the day, we just hire 10 graduate students and feed them bread and water and whip them and make them spend 2 years of their life doing this. And, instead now we hire one graduate student and we, give them some AI, machinery, and a year or two later they come back.
Well, I keep hearing,
answer.
because the stories about this black hole story that came out too, they said, they used a lot of AI-based kind of number crunching for that, and then there was LIGO, and then as well as with the LHC, that they had used a whole bunch of AI technology just to crunch at the massive amount of data that clearly came out. I mean, that's a lot of grad students, right? I mean, and that's a lot of PhDs. But I mean, we would have been here till the year 3000 if they were just crunching at it.
Absolutely.
So there clearly seemed to be kind of benefits in
absolutely.
that regard.
Absolutely. There's a ton. There's absolutely a ton.
But from your scope right now, I mean, because you're looking at stuff, and I wanted to bring it back to to you and what you're doing a little bit, because again, these are areas that are both fascinating and frightening. You're looking at stuff that's really far out. Do you use a lot of kind of data analysis techniques to be able to look at all these things that are super far away and figure out the nature of them and what's going on?
Yeah, I mean, so we're always trying to do fancy image processing. I mean, one of the things that's horrible about my field is so many people keep up with astronomy and they see these beautiful pictures, these press releases from Hubble, all this stuff. And, my parents, they're like, why don't you take pictures like that? But, when you're looking at...
Why can't you be like him?
Exactly. But, when you're looking at the most distant galaxies, they don't look like anything. We see these little faintest flecks of fluff in the longest exposure that Hubble takes, and we're like, I think that's something, and we have to get there, and we spend a lot of time figuring out what noise is, because we have to decide if the thing we've seen is just
that little speck.
Yeah, is that static? Is that noise? Or is that actually something? Because we are looking for absolutely the faintest, most distant things, right? So we're doing all sorts of sort of fancy image processing to figure out, this is signal, this is noise, this is statistically something, this is statistically not something. So unfortunately, though, it doesn't make for beautiful press release photos, right? Where I can show you these distant galaxies, and it really just looks like if you squint, and you have to squint the right way, and you have to turn the image a little to the left, that there's a fluff ball there, right? That's kind of what we've discovered. And so, it's a lot of work on image processing, really pulling out incredibly faint signals.
So you've got these signals that are from really far away, these flecks.
Yeah.
You told me that the universe was expanding.
Indeed.
Does that fleck go away eventually?
Does the fleck go away?
Does it go beyond, eventually? And I don't know if I'm asking it the right way. And sorry, correct me. I'm asking from a layperson's point of view. You're telling me the universe is expanding, but does that fleck eventually become more and more red to the point that it goes away somewhere, and beyond which you can't see?
Yes.
There's some boundary, and then what happens? If you extrapolate this long term, what happens? Is there something beyond the beyond, and is that more philosophical or scientific? And this is the second part of my frightening question.
Do you want the long answer or the short answer?
I want you to educate me.
Okay, so the short answer is maybe.
Okay.
The long answer is we don't really know. So things are moving away from us. However, they're not moving away from us at the speed of light. So if that's true, then we'll always be able to see these things if you think about it, right? It's only if they started moving away from us faster than light that they would eventually disappear. Does that make sense?
Well,
So if I run away from you,
Right.
on the street, which probably I've done at some point in our lives, running to class, I don't disappear. I am moving away from you, but I don't disappear because I'm not running faster than the speed of light. However, if I was really late for class and I got up to the speed of light, then I would eventually disappear. So the question is, will anything ever be expanding away from us faster than the speed of light? And the answer is maybe. We don't know. So about 20 years ago, there was this discovery of this thing called dark energy, or that the expansion of the universe is accelerating. This was, for your younger listeners, this might be new, but for people our age, this was kind of right when we were in our 20s. They won the Nobel Prize for this, right? Discovering this dark energy accelerated expansion of the universe. And so we don't know what this thing is that is causing the universe to inflate faster and faster and faster.
Now, is this thing that they were related? Because I remember it came out in like '98, the big
Exactly.
rip they were postulating about, and that things aren't moving, but space itself is somehow expanding. Now, is dark energy part of this expansion of space for a reason that we don't know of? Is that all related to it? Because I only just read like a Time magazine article in like '98.
You're absolutely you are absolutely right. So in a normal universe, you'd think, okay, well, it would start expanding. It's got gravity in it. Gravity's attractive. It would start to slow down. And our universe is the opposite. Not only is it not slowing down, it's actually speeding up how quickly everything is moving away. And so we've given this thing causing this speed up, dark energy. We've given it this name, dark energy. What it is, we have precisely zero idea. We have absolutely no clue. There is no particle theory. There is no understanding of it at all, what dark energy is. We know it's there. We can see its effect. We can see the universe accelerating, but we don't know. And so, trying to circle back to your original question, which is, will these galaxies eventually disappear? The answer is actually, if dark energy keeps behaving the way it does now, yes, they will eventually, because the universe is accelerating its expansion. And at some point, things far away from you will actually start moving away from you faster than the speed of light, and you'll lose sight of them. Right?
So where do they go? Do they just go beyond this causal boundary of sorts? Like, we can't see?
That's kind of the way to think about it, is that if something is moving away from you faster than light, then you can't see it anymore. The light can't get to
is there
you.
stuff already there right now? Like, in that sense, is the universe infinite, or is that even a right characterization of things?
So no, well, we don't think so. But again, I mean, you're cutting right at the cusp of all the things we don't know. So we don't think so. Our horizon is quite big. We can't quite see back to the Big Bang, but it doesn't matter because there's stuff in the way anyways. So we can see very, very close to the Big Bang. We see this thing called the cosmic microwave background, which is like a whole other hour-long podcast. So there's nothing there, we think, yet. But as I said, if dark energy keeps on doing what it's doing, then eventually that will happen. Now, the thing is since we don't know what it is, it could change its mind tomorrow, right? It could be like, oh, I'm going to accelerate the expansion of the universe, and it got to a certain size, and you know what? I've changed my mind. I'm going to start contracting the universe, right?
Because so we literally know zero about it right now,
literally
except
zero.
For the effect that it's having.
Exactly, and
currently.
So we can't predict the future of the universe. We can assume, look, it's going to do the same thing tomorrow as it does today, and it's going to do the same thing the day after, and blah. And if we do, then what's going to happen is what you said, is we're going to lose view of all sorts of parts of the universe and what's called a big rip. But if it changes its mind, which it's apt to do if it wants to, if we understood what it was, then that might not happen. And
I can't.
And so that goes back to the short answer was, maybe.
So I can't accept this because it continues to bother me. And it's, this just makes me, and as silly as it sounds, these types of things genuinely do bother me.
They should.
I don't know what exists beyond, right? And while you talked about the link between math and astronomy, and math, I'd say, in my experience, has been it's concrete, and so based on your premises, if you follow certain rules of deduction, they make sense. And then based on the axioms that you tend to use from mathematics, or from set theory that you have, it kind of emerges from there that the maths kind of makes sense. Yes, there are kind of different branches of mathematics. They might talk to each other. Generally we try and use mathematics to be able to support kind of the empirical sciences. But here, the really kind of, discomforting thing in a certain sense is that there's so much that we just don't know. We probably know more about math than we know about, frankly, like how, from what you're saying, how stuff even works. I mean, there's everything from, string theory to, like loops and all these, the multiverse, and, it turns out DC Comics and these guys may have been right? So I mean,
Absolutely.
About the multiverse. I mean, is this stuff that you also kind of have to confront and talk about on a regular basis?
Yeah, absolutely.
So what is the multiverse?
Oh, good question. Well, I mean, so let me take a step back before I answer that and talk to what you said, which is like, it is scary how much we don't know, but go try to find a textbook from 100 years ago and realize how much we know now compared to what we knew 100 years ago. And it is absolutely staggering, right? It is staggering what we can talk about now in the realms of particle physics, the idea that people are taking pictures of black holes, that we kind of understand the origin and evolution of the universe, which none of this they understood 100 years ago. They thought the Milky Way was the entire universe, right? Captain's 1922 universe was the Milky Way, which is nothing, and so, and when you say, well, 100 years is a long time, but you think, yeah, but actually it's really just one human lifetime. Well, I mean, a very long human lifetime, but it's literally one lifetime. We've gone from understanding so little to so much. So it is scary how little we know and all that kind of stuff, but it's amazing how fast we're actually moving. And it could well be, you've got a young boy who's 4 years old, right? And he may live to 104. And, what would be so cool is if this podcast, was kept, and 100 years ago, 100 years from now, he listens to this and goes, oh God, they were worried about all that stuff. We solved
how
that.
quaint. Right?
Yeah.
They thought the elements were like earth, air, fire, and water.
That's right.
Like,
we solved all of that in 2085, So, things like multiverses are things that, so you asked about multiverses, are things that people are talking about. 30 or 40 years ago, if you said that to a theoretical astrophysicist, they would probably laugh at you, right?
But it seems to be in the here and now where
yeah,
people
absolutely.
are like taking
absolutely.
it seriously. But it was that ridiculous back then.
It was, I mean, it was pretty ridiculous because there was no need for it. And now, we know so much about our universe on a cosmological way that we start asking deeper questions, which is like, okay, now that we know all the bits and pieces to pretty high accuracy, where did it come from? Why does it look this way? Why is the force of gravity this strong? Why isn't it stronger or weaker? Why is the ratio of mass between a proton and electron what it is? Why is the electric charge the value? These kind of things that could have been anything, but are what they are. And so, this is the kind of thing that has then led people to talk about potentially multiple universes, that, oh, well, in other universes, they are different values. You just so happen to live in one of, millions, if not infinite, universes, and this one has all these kind of properties, but they could have been something else. And it's a little bit comforting because in science, it's very uncomfortable for us to have these kind of built-in numbers like the strength of gravity, or
like these magic numbers that are just these
magic.
Constants.
Yeah, they're magic, right? And we have no idea where any of those come from. And multiverses are a way of trying to deal with that in some way. The only problem with it is that it's very difficult to test. People can write down theories of multiverses, but if we can't see them or talk to them, then it's hard to distinguish if it's right or wrong. But, who knows? It could be that in 100 years we find ways of actually, potentially seeing information transferred between different universes, right? Who knows? Maybe there is a way through black holes or something like that. We really just don't know. I mean, these are things that are on and I love these questions because these are frontiers that are even beyond our current frontiers. I mean, these are really the kind of things we dream about in the future. But, it's easy to imagine that in 100 years, these will be absolutely the forefront of science.